Okay, so we're going to be reviewing the discriminant. Now, if you guys remember this, the discriminant is just a formula that lets us know how many roots a quadratic has. That's it. Now, there's three options, basically. A quadratic could have two roots, as pictured here. So you see, it has two roots, and a root is just, that's right, where the parabola hits the x-axis. So that's two roots. All right. Another option that I could have is one root, and that's where it just kind of kisses the x-axis at one point. Okay, that's the x-axis, and it just touches it at one point. And finally, you could have a, what's it called? A quadratic that has no roots, and that's where it doesn't even touch the x-axis. It's above it. All right. It could also be below, also no roots. Now, there's a formula that helps us figure out how many roots it does have, and we don't have to graph it or do anything fancy. All we have to do is use this formula, and it's b squared minus 4ac. All right, that's the formula, b squared minus 4ac. And there's four different outcomes you could have when you do this. The first one is that b squared minus 4ac, which, by the way, just comes from the quadratic formula. That's everything underneath the square root. If b squared minus 4ac is greater than 0, then you know it has two real roots. All right? If the number that you get when you plug into that formula is a perfect square, then you know the roots are rational, or they're not irrational. The second possibility that you'll have is that, once again, b squared minus 4ac is greater than 0, but the number that you get is not a perfect square. So, for example, if you got 38 when you plugged into this formula, that's not a perfect square. So therefore, you would say that it's not, then you know it's two real roots, but they're irrational. So if it's not a perfect square, you have irrational roots. So a perfect square would be like 4. That's rational roots, 38 irrational roots. Third option is that the discriminant is equal to 0. All right, you plug your numbers in, you get 0. When it's 0, that just means that you have one real root. All right, one real root. Or another way to say that is two equal roots, right? Because that would be like getting 3 and 3, which is just the same thing as getting one root or two equal roots. All right, so when your discriminant is equal to 0, you plug in your numbers, you get 0, and you know you have one real root. Or another way of saying that, two equal roots. And finally, when you get b squared minus 4ac is less than 0, then you know you have no roots. And another way of saying no roots is to say they have complex roots. And remember, a complex number is just an imaginary number and a real number. So it's really just saying imaginary roots. So this guy does have roots. They're just nowhere in the real world. Blow your mind. All right, so this is a Regents question. Let's take a look at this one. We want to find the roots of the equation are like what? Well, we just set up our equation, b squared minus 4ac. All right, we're going to find out a little bit with this. That's our discriminant. We're going to just plug into this formula. All right, so our a is equal to 1, our b is equal to -6, and our c is equal to 7. Well, so we're just going to do -6 squared minus 4 times 1 times 7. When I plugged into that, I get 36 minus, well, that's 28, which gives us a number of 8. All right, so that's a positive number, so I know that they're not imaginary roots, all right? And I know it's not 0, so I know the roots aren't equal either. So it's down to these two. There's two real unequal roots here, right? Now we just have to know if it's rational or irrational. That's really the only two differences here. Is it irrational or is it rational? And the way to figure that out is just to look at this number. Is this a perfect square? Nope. So I know the answer is irrational. All right, that's it. You just have to plug into your formula, look at this number. This is your reference sheet to figure it all out, and you'll be good to go.